Howdy guys, welcome to another stats video. Today we're going to talk about two proportion hypothesis tests. We call it a two prop z test. Okay, we've talked about a one prop z test. Now we got two. So I'm going to work one of these and you're going to have one for practice, okay? So is Lonzo Ball a better free throw shooter this year than last year? Last year, Lonzo made 20 out of 48 free throws. This season he's made 30 out of 53 free throws. So we had a problem like this for confidence intervals. Now, is he a statistically significant at the 0.05 significance level better free throw shooter this year? Or is it likely just random variation in his ability? So the parameter, we're going to have two parameters. Remember, parameters are actual population, in this case percentage or proportion. So we're going to have P from last year, and that's Lonzo's true prop proportion of shots made last year. Then we got P current for this year. And that's the same thing for this year. Okay, now there's a parameter and a related statistic. So we call the statistic for proportions P hats. This is P hat of last year. And P hat for this year. My P's look different, but they're not. Let's fix this. This year. Okay, so for last year, he shot 20 out of 48, which is 0.4167. This year, he's shooting 30 out of 53, which is 0.5660. So you can tell just by looking at it that this year's is better for this sample. But we're trying to show that this proportion, the true proportion, is higher than last season's, because we only have two samples, right? One for this year and one for last year, two proportions. So the hypotheses, the null is going to be that P last year is equal to P this year. And remember, these are always going to be P's as in not P hats, okay? The alternative is going to be that last year's was less than this year's. These look like capital P's. They're not. These are subscripts. Little p subscript last year equals little p subscript this year, so on and so on. The significance level, they tell us, is alpha equals 0.05. The name of the procedure is going to be a two proportion z test. And our conditions, we got, is it random? We're going to say yes. Random samples are given. I'm going to check the 10% rule. Yes, in this case, samples were less than 10% of all shots taken by Lonzo in the history of Lonzo shots. And then large counts, we've got 0.4167. We're going to multiply that by 48 and get 20. That is greater than or equal to 10, and that's one of the four that we're going to check. We're going to do 1 minus 0.4167. Multiply that by 48. That gives us 28, which is at least 10. and then we're going to use the other p-hat, 0.5, excuse me, 5660. Sixes look weird. I don't know what's up with that. Times 53. That's 30, which is at least 10. We're going to do 1 minus 0.5660 times 53, and that's 23, which is greater than or equal to 0. Sorry, 10, not 0. So all those guys are greater than or equal to 10, so the large counts are satisfied. Remember, it's random independence, and is our sample large enough? In this case, are our samples large enough because there's more than one? So the calculator steps, nah, not this season, this year. We're going to use the bookmark site. Okay. And it's going to want to know a couple different things. Sample, the site will take that excuse me, I'll try that again. The site that the link will take you to run this, to find your Z statistic and your p-value. We'll ask for sample proportion 1, which we're going to say is 0.4167. We'll ask for sample size 1, which we're going to say is 48. It will ask for sample proportion 2, which is our other p-hat. It will ask for sample size 2, which is 53. It will also ask you if you want a one-tailed or two-tailed. It's going to be a one-tailed always, unless you have a not equals alternative hypothesis. And we don't. Our alternative hypothesis is less than. Okay, we'll come back to that picture in just a second. Let's go find the test statistic and the p-value. Hang on just a second, and I will get that cooking. Okay, so this is today. We're going to click on this hypothesis test for two proportions. And our first sample proportion is 0.4167. That sample size for that sample is 48. Second sample is, this is our second p-hat, 0.566. It's already in there. And the sample size is 53. Okay, desired significance level, 0.05. We're going to do a one-tailed, so click on the 1. Remember, we're only going to do this two-tailed if our alternative hypothesis is not equal to. It's doing the spinny wheel thing. I know that's kind of off the video, but okay, we're good. You scroll down just a little bit, it'll give you the results. It gives you a 95% confidence interval. We're most interested in the Z value and this p-value. This is a Z statistic, and this is our p-value. This Z is saying that if we got the samples we got, we are 1.5 standard deviations above the mean. So that's going to come into play with the picture for just a second. And the p-value is, if the null is true, the probability of getting a Z value 1.5 standard deviations above the mean by chance is 0.67. So it even helps you with the interpretation. It says not significant, except the null hypothesis that sample proportions are equal. We don't ever accept the null. That's a no-no. So this is a perfect example of somebody that's smart enough to write this tool, right? But doesn't know statistics enough to know that you never accept the null, right? We reject the null, and we fail to reject the null, but we never accept the null. Okay, so I'm going to stop here and we're going to fill out the rest of our notes. Welcome back. Okay, so the Z statistic was 1.5. The p-value was 0.067. I'm going to draw a quick picture, and I'm going to draw one of those normal curves that y'all love so much with the center, and I'm going to do 3 standard deviations above the mean and 3 standard deviations below the mean. We are falling, because our z value is 1.5, we're falling 1.5 standard deviations above the mean. Okay, and so this is our picture. So this is the probability that z is greater than or equal to 1.5. And that's our p-value, 0.067. Okay, so what are we going to conclude then? Well, we're going to say for alpha equal to 0.05, since p equal to 0.067 is greater than alpha equal to 0.05, we fail to reject the null. There is insufficient evidence that Lonzo is a better free throw shooter this year. Okay, so if you need help with this next one is going to be y'all's to work on for practice. If you need any help with this, just join office hours and I can talk you through it. Adios.